Okie doke. It is time to begin. Didn't do the self-test yesterday because I only had the stamina to do an hour of the regular learning, so not even what I wanted to do. But it's because the day before my sleep was bad because I had to make a presentation and stuff, present some data and things for a job interview at my job. So, excuse me, sleep is good. I'm good. Let's get it. Recording? Yes, cool. Okay, so last time we had a lot of fucking lessons for damn type aliasing. We don't even need to include anything here. So yes, now we know that we could do, what is going on here? We do not a using declaration, but a type alias using statement, I guess we call it. Like using thing, so this is the using alias. And then we assign it to be, we'll just do an integer. And then later on we could say, trying to fix my chair. There we go. Later on we could say alias height 30 and then boom, and then I can do whatever I want with it because now alias is a way of saying integer. But there are some issues here. Same thing with doing type def height as alias like this, and then we could do the same thing, but I think there's a compilation or yeah, because this is already being used. It's not a type name. Well, hold on. 6 is saying it's not a type name. Oh, wait. Oh, because height is, we'll just say thing. Oh, wait. I didn't, this should be int, not fucking height, Jesus. Oh, wait. Oh, it is the other way around, duh. Int, okay, so this should be, so we can do using and then the alias as an integer. So now we can say, using alias is integer, and then we can have alias height is 30, which is really, this is an integer, but type aliased. Similarly, we could do type def int, and we're now using something for int, and we'll call it alias 2. And now we can do alias 2 width 30. Cool. So now no errors, we're cool. The only thing, these are just warnings because we're not using these variables yet. So, because I have treat warnings as errors enabled, the only thing here is that, was it another language it said? I think it said, not this yet. Oh, some languages. What does it say? Doesn't even say. Okay, well, there are other languages that would make it so that if we did width and assign it height, strong type def languages would would the reason it would generate a compiler error here is because we would have a type mismatch. Just like assigning, not necessarily a narrowing conversion, but maybe it would be, would it be a warning? Well, yeah. Because mixing our type diffs, or mixing our type aliases. Because maybe we want we get iostream. Oh, actually, we don't even need that. We need string. Why is my throat fucked up? Okay, I think I'm right. We could say using villain is standard string. And then now we could do villain Jack, and like this. So we could use villain to be one type of name, or villain name, and then we could say villain name. But then we can have another that's type def standard string hero name, and then we could say hero name Jill, whatever, like this. So we don't want these two to mix. Don't want villain name and hero name to mix because they have different uses. So we don't want this to work. Jill is Jack. Here it works, but we don't want this. Strong type def languages. Error here because type mismatch. Or type alias mismatch / mix. Okay, so yeah, we can do type def as well, but we prefer it here because it's not as clear. When we're looking at type defs, it's not as good as just a using alias, because when we do a using alias, there's an equals sign assignment, equals, what? An equal sign in the middle, and it seems like the logic is different, like where for pointer stuff. We don't say pointer of function type or int. I don't know if you need this parentheses shit here. I think you could just do pointer int. Maybe not though. I don't know if that's right. Maybe you need something in a parenthesis. I don't know why you would want this. From what I saw with pointers, you just do like int and then pointer, or int and then pointer to the name. So this is pointer to the name. This is int pointer. But I don't know why we have these parentheses here. At least with how the operator works, I don't think we need this unless there's some extra requirement that I'm ignorant about. Just like maybe just like a comma. Like comma, I don't need this, then this. I want both of them. We don't need a comma here. I don't know if we need this, but we'll see. Yep. So assuming that that type defs are less clear than the using, it's better to do a using type alias. Okay, so these are called type def versus type alias. Okay. In type def, suggesting that a new type is being defined because we are defining a new type, but instead we're really just using this as this. So we're using something to call, or to get an integer. We're not actually defining something that's unique. There's nothing unique here. It's just an alias. Same shit, different name. That's it. Type def names are type aliases and type defs. Type def is normally meant either. Okay, well yeah. Yeah, we're just renaming an existing type. When should we use them? Useful for platform independent coding. Oh, so like what? You include a header file if you're on this software where you call it via int8t, but on this one you have something else that you name it. But you include the same header file, so your code actually works the same way because it's just using the same name. It's to hide platform specific details. On some, an int is 2. On others, it's a 4. Using int to store, on some it's 4. Can be potentially dangerous when we're writing it on platform independent. Wouldn't it be platform dependent, or we're talking? Oh, we're saying writing platform independent code, meaning we're writing codes for multiple platforms. If we do that, and you happen to be on the platform where ints can only store 2, but you're trying to fit 4, then you might get some wraparound action. You get -127 instead of 127, or instead of expected 128 or something. Yeah, because you think it's, well, or you think it only holds 127, but you try and fit more into it, and then you end up getting negative 32 because you tried to fit like basically about 200 in it. Yeah. So cross-platform programs explicitly define the different types that use specific memory values. Because if we use an integer or a float or something, or well, if we're talking integral values, character, int, long, or oh, there's short too. So character is 1, short is 2, int should be 4, long should be 8. 16. Oh, I don't even know. I guess and long is like guaranteed 8 or something like that. I'm not sure. If it isn't clear from the name, well, and that if we use the names as shorthand, and those are implementation specific, and they depend on the implementation, like on my shit, 64-bit system, I think, or 86, whatever the fuck the default Windows is. And we use character, I assume that it's 1 byte. Someone else's, maybe it's different. I assume an int is 4, a long is 8, and a short is 2. For someone else, maybe an int is also 2. So for me, I can use short. For them, maybe short is actually even smaller. So they just have int, but they don't even have short. So we need some way of, if in the program we explicitly need this much memory, well, on this platform I need to call, well, let me see. Yeah, on this platform I need to call an int 8 or an int, like on the smaller platform, maybe you have to call an int 16t in order to get, or an int 32t in order to get access to a 4 byte int. But on my platform, I just call int because int by default is 4 bytes. The solution here is we, in the header file, define int 32t as whatever the hell we're using. And then we just use that. That way on my end, I'm using that, and it works. It's getting int 32t. And on the other one, it's that. So we could just do int 32t on both sides. I mean, I guess that would fix it, because the language doesn't change. It's just the implementation. Or, sorry, it's just the, well, yeah, the implementation, the shit that's going on back, or behind it. Platform specific. Platform, yeah. Or in this case, well, in this case, it seems like there are actually unique things. Because there isn't just an int and a something and a something, and they're all platform dependent. There are some that are actually not platform dependent, and those have specific type names. I think if you're going to, well, I mean, you could just do int 8t on both. But it sounds like it's saying that, by the way, buddy, the int 8t, int 32t, 16t, 64t, etc. are all themselves type aliases. But type aliases of what? What are the actual names? Well, underscore t is that, so it seems like it is actually type alias, or like a size t. But it's a type alias for something that already exists specifically. Because if a long isn't guaranteed to be 8 bytes, but an int64 is, then int64t, if that's not actually the original name of it, maybe it's the gonna say it's the something version, but it's already in the bit version. I don't know why would we want, or what int64t would actually be beforehand. Whatever, it's int and then some crazy ass number, or whatever the hell C++ defines deeper within. It makes sense. Yeah, because maybe someone else would make an assumption that's different from the code that you're already writing, they've already made. Or later on you're looking at previous code and you're like, oh yeah, that's an int. It needs 4 bytes, but it actually only needs 2. And then someone else tries to use it and then they use too much memory. Or, probably more likely, you're like, oh, it only uses 2. My hardware only puts 2 bytes in an int, but in reality it's actually doing 4 bytes. Well, someone else comes along and thinks, oh, okay, yeah, it's only 2 bytes, okay. And they use that and then it doesn't hold the whole value. And you're screwed. You need to be explicit. Excuse me. Excuse me again. Preprocessor directives. Meaning what? This is the header file that's used in every single file. So if we open up every single file, after compiling, or after initiating the compiling, but before, that way, after compiling, that way the header file is converted into code, but before the compilation finishes, and we go into a translation unit where it's all binary, before then, or we've just added the code in, and then we've added anything else that's hidden, or at least maybe we just expand the header files. If we see that's the case, it seems like the IOStream one, or C standard int, would have int 8t, int 16t, and 32t, so it's part of the standard library probably. We don't have to say, yeah, it's there, but it's in global scope, that's why. Because we don't have to say standard to get it, it's in global scope. We're just including it. So including a for declaration, the regular shit is somewhere else in the 20 gigabytes of shit that I have on VS Code, I guess. That way every single file has that shit. Therefore, if something in the operating system or something in the IDE, or like the installation of the IDE, maybe you install this IDE versus that IDE, or this compiler versus that compiler, the compiler knows what operating system you have, it knows whether an int only holds 2 bytes or whether it holds 4. Therefore, if it holds 2 bytes, it will define it as this. Yeah. And int 8t is a character, and int 16t is an int, and int 32t is a long, but instead, so on one platform, a long is already 8 bytes, 64 bits. So we just need to say that, hey, an int 8t is a character, and int 16t is a short, and this is that. Oh, that's the point. I mean, no. Hold on. We're saying, we're referring to characters as 8, shorts as 16, and ints as 32. But on this other one, there is no room for short. Character is 1 byte, integer is 2 bytes. There's no short. Character is int 8t, integer is 16t or int 16t, and then long is int 32t. I need some music or something. KO. What am I looking for? Let's just listen to what I've been listening to recently. That's a good song. Am I playing it out loud? No, we're good. Alright, cool. I need to do push-ups or something for a second real fast. Super quick. I gotta wake up. I'm too fucking tired right now. I'm getting sleepy. Oh wait, I want the music. Alright, real quick. I'll do 25. 1, 2, 3. 8. 9. KO. Easy enough. I'm keeping the music on though. My hands are clammy now. Fuck. Yep, so we include them as preprocessing directives. Preprocessor directives, cool. Well, yeah, duh, if int 2 bytes is already included, which we would do, or maybe the compiler does, depending on what the operating system is, and that's like, what would that be, the first thing? We'll say it's the first thing that it's included. At the very first line, it's defined in 2 bytes. If it's whatever. Or it could be, if whatever, well, I don't know if it can have a condition, I guess not. Maybe it can. Maybe there's a preprocessor directive to get that value. Or maybe there's something deeper inside the IDE or the compiler, well, the IDE, that says, yes, this is good. If so, define int 2 bytes. Or maybe it's automatically defined. Yes, or it's 4, it will not. It will define as usual. Yeah, so it seems like at a base level, it does, these types do depend on the operating system. It's just, on this one, you use an int, it's fucking 16 bits. On this one, you use it, it is 32 bits. Therefore, on this system, we want to make sure to define int 16t as int, and int 32t as long. But on this one, we want int 32 or int 16t to be a short, int 32 to be an int, and int 64 to be a long, unless longs are already default 64, which it sounds like they are. Okay. Oh, it's all these three things. Yeah, I guess if you want to reference them all like that, because a character's a character, it's always one byte, no matter what, I think. But if you're using other ones like this, then maybe you want to say, hey, int 32 for this, int 16 for this, and then you don't want to say character for this, you just want to say what an int 8 is. Well, regardless, for both of these cases, in int 16t and 32, these are the same thing. 16t in both cases is a fucking 16-bit integer. It's just that one of these doesn't have short. It has int. Because then this would be int, and then there'd be no long. So regardless of whether this is defined correctly or not, even if it's wrong, int 8t is still a character, and 16t is still... Yeah, because on the right system, this is cool. On the other one, it's that, well, but we're saying if it's defined correctly. Meaning that if we're on the wrong system and we define it wrong, or if we're on one system and we define it wrong, then in 8t, yeah, I guess so. If you're on the small system and we have it defined like, and we flip these and it's not defined properly, I mean, this guy's defined, but these are flipped, then yeah, your int 16 would be a short, but then your 32 would be also a reference to an int, which in your case is the same as a short. That's why there isn't an int and a short here. Because this is an int and a short, so. He's fucking smart about it. Okay, it's self-explanatory, it's fine. You just type aliases to fundamental types. Gotcha. Uint in size t. Yeah. Yeah, it makes sense, because an int at is just a fucking character, dude. And then when we're on this system, a uint 16t is an unsigned int. On this one, a uint 16t is an unsigned short. On that, it's that. On this is this. Which is why we can do it differently. So we could say unsigned long. Well, on both they're an unsigned 64. But if we say unsigned int 16 or unsigned int 32t, on this one, that's an unsigned int. On that one, that's an unsigned long. Because a long is a 4 byte on the other, I forgot. Gotcha. I would like if there was a the to the various fundamental types. Yeah, it makes sense. Well, yeah, because it's saying, hey, look, if you do an int at, it's saying this is a character. So it's literally seeing what is the character here. Makes sense. It's saying, hey, print this guy as a character, we get A. Yeah, makes sense. That makes perfect sense. Yeah, I didn't know that it was not just a secondary type, some extra type that's more explicit. It's literally the same thing. So if we do int 8t, you're literally printing a character. So you have to static cast it to be a regular int to print it properly. Yes. It's a signed character. Yes. Complex types. Yes, that's what I thought. Oh, shit. God damn. God damn. What is that? What are these types? Oh, two different types. In advanced C++, types can be complicated and lengthy to manually enter. So we have vector and utility. Standard pair. I don't know what pair is, but we're pairing something. I don't know. Oh, standard pair, and we pass it two types. One, a string, and we're pairing it with an int. And I guess we're calling it pair list? I'm not really sure. Yes. It seems like we're defining it here, maybe. We're calling it pair list. Like there's a standard vector, and it gets some sort of template guy, and then we name it. So it looks like standard vector, less than, greater than, name. But in this, it needs to pair. So it could just be standard vector one thing, but in this case, we want like a... In this case, we want to pair them, I guess, as one type maybe, or something? I'm not really sure. Standard pair, standard string, and int. Yeah, so instead of entering this, we could just say, hey, a standard vector with all this shit is a whatever. Is a something. It's a vector pair string integer. I might lay down for a second in a minute here. Yeah, we're just using a type alias here to name that crazy type something else that's more, it's less cumbersome. Yeah. So we're just saying, hey, using vector pair string integer is now this. Cool. Instead of this type. It could be standard Mersenne twister, it could be standard random device, it could be... yeah. Yeah. Type aliases allow you to take complex types, give them a simple name. Cool. We could also document the meaning of a value. I don't like that. Well, I think if you make good functions, then the name of your function should tell the type of what it is. So like it should be get test grade or something. Something stuck in my throat. Should be, yeah, I mean, get test grade could be fine, or get test result, and then it takes something. I mean, it would be stupid to assume these. I mean, it has to be the grade. Make your shit more idiomatic, bro. Yeah. Test score to be an integer, and then test score grade test. Grade test returns the test score. Okay. But then what the fuck is a test score? I mean, it's capitalized, so you don't assume it's a variable or a type. You assume that if it's capital, it's either a namespace or it's a type alias. So it's gotta be a type alias. Test score. So the only digging you have to do is find out what type it actually is. But maybe that's annoying because I don't know exactly. Like, what is this? Is this a 16 int? Now I have to go and look to make sure it can fit. If it was an int 8t, I would know, oh shit, you can't get above 127 points in this shit, dude. Because that's the highest positive number that a character can hold. And that's, yeah. Yeah, because it's just 2 to the 7th. I don't really like this. I agree. The same type. Yeah, maybe. Oh, but instead, if you gave it a type and then made it integer, well, later on, you could just change it to be whatever you actually needed it to be. So, for instances where you're storing information and you're not sure, and you are not completely sure that later on the value you have will not be able to fit that. So, like if we make a program and it's it's like a reservation storage system for a restaurant, and we know that sure, in coming weeks they're probably not going to have more than 64,000 or whatever, something like that. Reservations. Sure, like that's a lot of reservations. Okay. But over years, there's probably going to be a time where they have more. So if we're counting the entire amount of reservations, well, we might have using reservation count as integer. And for now, it's okay to be integer. And then we use reservation count, whatever, current reservation, blah, blah, blah. And we do stuff to based on this number of reservations. But at some point, we need to store number of reservations. We need to store more numbers of reservations in the variable. All we have to do is just pop off, oh, it's no longer an integer. Now it's an int64, or it's a long, or whatever, it's a long, something like that. Boom, we're good, we're set. Yeah, see, so if we were using short to store student IDs, because we only thought we had maximum of 127, it's a 2 byte guy, so I don't know how much 2 bytes. It's times 16 power, so it's probably at least in the thousands. We'll say 20,000. If you only have 20,000 students, Well, eventually you become a bigger fucking university or something. Well, you need more student IDs. Now you have to make it a fucking, you went to make it a long. Now you've got millions of students. Holy. Yeah, like you had this little online system, and then later on it grew to something way bigger. It'd be cool if you just had a type alias for that. Then you could just swap that. Boom, you're good. Caution is necessary when the type is changed, because, like, if it was character to something else, and then we changed it, but some things actually were printing it as a character, and we needed it. Well, if we changed it from character or int8t to short, well, now none of those things that are printing characters are printing characters anymore. They're now printing the ASCII code. So it's printing 97 instead of A when we want it to be A. So, different family. Well, yeah, duh. Yeah, if we had an integer and then now it's a float, well, the values of an integer are represented differently in the float. So if we just change the type, the binary is the same, but the value that the variable is holding or is returning is different, because 0100 is different in binary from or is different from an integer as it is from a float. Maybe as it is from an unsigned, maybe, I don't know. Or signed to unsigned. Oh, well, fucking there it is, buddy. The new type may have comparison or integer floating point division issues. Let's see. Well, yeah, like if we were using it in one case and it was a float and we had floating point division things that were working, but later on we say, oh, we don't want a float, we want a long. We want it to be bigger, because surely a long is a float, right? It's not a double, it's a long. You accidentally say long instead of double. Well, if you change it to long, well, now your floating point division, well, actually your floating point division might be okay. Well, no, if you change it to long, any values you have that used to be floating point values are now all having narrowing conversions, because you're going from, well, you're going from float to long. Yeah, a long is a narrowing, even a float to a long, even though a long has more memory allocated to it likely, it still has a narrowing conversion because it can't fit all the values. So narrowing conversions aren't necessarily always going down in memory, like, oh, we're losing memory. No, you're losing data. That's what you're losing. There's some data that can't be stored. It's like you're handing off stuff to somebody and the guy is dropping the shit as you're giving it to him. Well, don't give it to him. He's got shaky hands. Don't pass a fucking float to a damn long, buddy. Unless you're explicitly doing it and you know that you're doing trailing zeros or something that where it's fine. Yeah, and comparison issues, just like a float. So if it was non-decimal and now it's decimal and now you're comparing them, well, now there's probably a lot more falses than you'd expect, because now 0.1 plus 0.1 plus 0.1 does not, or 0.1 plus 0.1 plus 0.1 plus 0.1 all the way up to 10 does not add up to 1. 10.1s does not add to 1. Actually, 100% won't if you're still treating it as a long, but no, because you'd still get floating point stuff there. That's the common type. Integral types become floating point types. No matter what. Due to the usual, what do we call it? Usual conversion, usual arithmetic conversion rules. Yes. I mean, it really doesn't feel like changing an integer, an int2 or an int16t to an int32t would have any repercussions. I mean, you're probably not planning for intentional wraparound, so it's not like, oh, I liked wraparound here, but maybe there was some. Well, I guess that's the point. If you had times where the value was working still, and you implemented some other things to get around it, and you didn't realize that the issue was wraparound, and you just added numbers to it to make sense in the end, like, oh, if it's negative, then add shit to make it positive. Well, if you change to an int 32t from an int 16, well, now if you still have that add shit in there, your values are going to be too high actually, because there's no wraparound and then compensation. It's just going to be too high. Not only is there no wraparound, but there's now no wraparound, and there's still compensation in there. So now your values are getting much higher than they're supposed to be, and probably unpredictable. Because you're like, oh, I'm used to getting the value 2. Now it's 5. Why is it 5? Or we're used to getting like, yeah, 5. Well, the reason is because you'd wrap around from 127 to -1, and then you'd add extra shit to make it work. Or, well, yeah. Or to negative whatever, 120 something, and then you'd add like 150 to it. Well, now there's no wraparound. You had 127, but then you went over it, but it was okay because it's an int 32t, not a 16t. You don't have, oh, well, an int 16, not an int 8. And then you added the 127 to compensate to bring it back to 0, and now you're screwed. I mean, in that case, it should be an off by 127 error, so it should be predictable, but. Yes, another fucking identifier, dude. This is why I don't like this so far. Use them judiciously, not all the time. Ooh, quiz. Like it. What is it? Oh, I think that's easy enough. This is why I've been adding all these critiques just in case, because I didn't think doing hero name and villain name is actually a good thing. I'd rather just do standard string, like so I know that they're the same shit. Yes, and I think it's hard in order to get this benefit. Yes. Yeah, I agree. Yeah, like if we have a pointer to an integer, and we change pointer to an integer to be this type instead, well, how the fuck do you know it's a pointer to an integer? How do you even know it's an integer? It could be a pointer to a number, a float, something else. Alright, this goes hot. I need to just look at this real fast. Oh wait, DMCA. Oh, it's that band. Oh shit. Yep. Yes. Well, yeah, meaning, well, I'd rather say a type alias is most useful when it can be used in multiple places instead of few places. Because we want to use an alias when we can use it a lot and it's helpful and it makes all this shit more readable instead of making it just to make this one little thing maybe better, but not really better. No, not fucking YouTube Shorts, bro. I'm trying to find a song. That's a good one. In the following function prototype, print error, okay. Using print error it as gets an integer, or gets integer. Type alias statement in the updated function prototype. Yo, that's way too easy. What's it called? Int print data. Okay. Well, now it's instead, it's using print, or sorry, using, what is it called? Print error. Using print error as an integer. It's that easy. Print error, print data. And whatever, we could do... I mean, this is not what we would want, but... whatever, the code is 3, and then return print error. Oh, what? Hello? Oh. Oh. I didn't name it. That's why I don't like that. Like, what do we want to call it? Print error is what it is, but then what do I... Error, I guess? I don't like that. And then we just call fucking print data. Bro, who is with? Oh, okay, it's just an old compiler error. Bro. Alright, we're good. Bro! Yay! Type alias. Why? It's one case, and I'd rather just have this be an int called type alias, and then this wouldn't be... I guess it's for cases like that, where you could say... Like... Maybe that's helpful. So if you have a bunch of functions, yeah, I could see that. If you had like a library or a namespace of a bunch of functions, and they all are void, they're void functions, they're not returning anything, but really, like, so their side effect is the important thing. But you still want them to return something so that we can tell whether they're correct or not, and we can test them. Maybe you make them return something, and you have using error code as integer, and then all of those return error code. That way you can test, hey, is the error code for all these 0? Cool. And not, what integer does print data return? Instead, it would be error code print data. This shouldn't be print error. That's like error of a print. I'd rather just say print code. Nobody gives a fuck that it's a print error. If you're printing data and you're returning a number, you're probably returning the number of data. But if your thing says error code, it's fine. You don't need it to be print code. You want it to be a type that a bunch of things are going to be using. This is a bad case or a bad use because how many times are we going to be using print error? How many print functions do you have that you're going to use print error? And you're returning a print. I'd rather say error code or something. Print error doesn't tell me anything. I don't like that at all. Let me wash my hands really quick. My hands are still fucking clammy. It's pissing me off. Oh, I'm probably kind of hungry too. All right. I'll try and stay up. All right, I'll finish this and then I'm gonna once I'm done here, I'm gonna cook and make some chicken cause I need some food. I made linguine alfredo last night, but I refrigerated it and I'm tired of that shit. I don't want it anymore. Excuse me. I could still use the cheese and the cream, just in different dishes. I don't want. I'm fucking tired of it. It's annoying now. Bro, I just clicked this and it didn't load. Fucking why? Bro, is this shit just looping? I need a different song. What is it doing? Alright, now we're cooking. Alright. Not a good use case. It's not useful in different spots. Cool. Yeah, easy enough. Print errors in. Bum. Auto. Here we go. I feel like this is gonna be another one of those cases where we say, like, maybe it's useful sometimes, but like if we do auto something as this, then I have to know where it's being used. I'm gonna guess that this is not super long. Yeah, see, when the type of the object doesn't matter. Favorite explicit type, when you need a specific one, probably. Maybe. I'll find out. Alright. There's a subtle redundancy lurking in this simple variable definition. Hold on. We have a double, and we're initializing a double. Oh, well, I mean, we already know that a data type is a double, and we're assigning it to a double. But the type should match. I don't know. I mean, sure, it's redundant, but just like if we're assigning 1 to a bool or true to be a boolean, well, when the compiler sees true, it knows, motherfucker, that's a bool value. So we're basically saying a bool value is being assigned to a bool. Is it redundant? I don't know. I mean, we are required to provide an explicit. I mean, I compared it. You could just say D and then initialize it as this, and then that's it. What is D? It's the type of this. But then you have to know the type of this. You don't see this and just know it's a double and then you can look next. You have to actually read the data and be like, oh, what is 4.9? Oh, what is 4.9997643218884? Fuck, that's a double, or maybe it's a long double, I don't know. Does this make noise? There we go. Yes, also has type double. Well, yeah. Yeah, I mean, that's probably the case where you usually probably want a fucking variable and its initializer to have the same type. I thought there was more water in it. Type deduction for initialized variables. Type deduction, type inference. Compiler determines the type from the initializer. So it says, hey, that's a double. This guy's a double now. You say auto, double. I, int, x, int. Auto. Yep. There was a bug in the language. Who'd have thought? Oh. Because an initializer list could have multiple things. Oh, and maybe that's why a seed sequence we were saying before. What would happen if we did that actually? Initialize the seed sequence with multiple initializers, but with the comma operator, but Not with brace initialization, but copy initialization. Cool. But what if we did... Yeah, no good. An int to standard seed sequence. Yeah, it's expecting a list, it looks like. So you have to initialize a sequence with a list. So whenever we do an initializer list, we're just only giving it one argument, parameter? I don't know what it would be in this case. Because it's an initializer list with type double inside it. This will be cool once I understand all this, dude. That'll be nice to be fluent in. Yeah. Well, yeah, it's an expression. It has a fucking result, bro. It evaluates the result. Yeah, we call this guy add, and we have an auto sum initialized to be whatever type this guy is, which is an int. Oh, okay, so we could specifically make this auto be a float, or we could specifically make it be an unsigned int. Cool. It's extremely satisfying to recognize stuff like this and just know what's going on in coding now that I've been at this for... this one. Where's the fucking... What's the oldest video? How long have I even been doing... How do I... Is there not a fucking end page? There's no way. It's gotta be... Is it not date? What is this? There's no date? But there's no way there's a first page, but not a fucking last... Where there's no way. Oh my... Oh, now there is? Why only then? February? I've been at this shit for 4 months? Oh, ain't no way. Oh, hell no. There's no way. Oh, wait, but February, March, April, May? Oh, it has been. Oh my god. Oh, but I started late February, so really it's been all of March, all of April, all of May. It's been 3 months. All right, fuck off. It's fine. That means I can get through the whole thing in... Yeah, that means... Yeah, it's been 3 months, and I'm 10 chapters in, so it's a little over 3 chapters a month. It's not even bad. That's actually fine. It's about right on pace. Which means in 4 or 5 more months, yeah, I'll be 14, 15-ish chapters in, or more than now maybe. And that's it. I don't even need to go that far, I don't think. So yeah, I'm on pace. And I'll probably slow down a little bit, so 23 chapters in, I'm good. How far would I be? Oh yeah, bro. Yeah. Const auto, so we could say, oh, that's an integer. This is a const, whatever the fuck this guy is, which is an integer. It's a const integer. Const expression integer, same thing. Interesting. So type deduction is done at compilation then. It's known at compile time. Yeah, it makes sense. If it's default initialized, it's not going to know. Unless, in that case, it did undefined behavior with a garbage value, but wonder what would it say? I'm used to value initializing. Womp. Must have an initializer. Can't deduce auto type because no initializer, boy. Well, what? Not even value initialization? No way. That would be stupid. Oh, really? Auto doesn't work with value initialization. Noted. Excuse me. Hiccup burp. Oh, and foo's void. See, yeah, that's what I thought. What would it say in that case? No void. Can't make a void variable. What if we did that? This use is not valid. Holy. Bro, only saves a few. Oh. Interesting. Well, yeah, I mean... you have to be really smart then, it seems like, or at least you have to be accurate with and purposeful with, that's why I said explicit in the beginning, that's probably the same. You have to be very specific about the types that you're initializing something with, because like if we're doing something that takes an initializer list as an initializer, like a seed sequence, if I said auto, or instead of standard seed sequence something, if I just said auto thing, and would that work? Let's find out. Auto my seed sequence, or we'll just say empty seeder or empty seeder. Yeah, sure. 1 1 1 1. What? Oh. So you can only... yeah, because it doesn't know. So auto isn't smart enough to know with multiple parameters for a brace initializer. Okay, that makes sense, yeah. Because if this is a standard C, or we could just say using standard seed sequence. Now I could just say seed sequence empty seeder. Am I a retard? Oh, bro. Now we're cool. But it won't know that because, bro, this could be anything. Who knows what the fuck? This shit? Bro, what the fuck? This could be anything. Who the hell knows what that is? It's a list of something. Is it a fucking vector? Is it a fucking... yeah, is it any custom type? Nobody knows. But if it's a one specific value and it's obvious, then okay. Like a, Well, I guess it's tough with the object, because I was thinking, what if we did, like a Mercer and Twister? Oh. Let's try that. Make a seed sequence, no deduction or inference, but then auto something to seed it with that. The seed sequence is the initializer. Will it know that it's only a Mercer and Twister that gets a seed sequence? I don't know. I don't even know if that's the case. Ooh! We're cool here. So the auto is failing, it looks like. Bro, what are you talking about? Yeah, so these are all compiled things that I've downloaded. That's the whole 20 gigs. I was right. I was guessing earlier. Referencing a deleted function. Yeah, auto's fucking up. What is auto seeing here? Oh, maybe it's thinking that it's a, maybe I think it's trying to get a reference to an object. Or, sorry, a reference to, yes, an object, something that exists, but it doesn't exist. And the object is a seed sequence. So it's like, oh, that's what's happening. I forget, it's not going to do a Mercer and Twister because it's not doing something that gets seeded by something. It's assigning the type to match whatever it is. So if we're initializing a seed sequence with a seed sequence, it's going to try to initialize as a seed sequence, but then it has an issue. What? Is there an issue with initializing a seed sequence with a seed sequence? Motherfucker, what happened? You should be fine. It's a call to that, huh? Are you kidding me? Dive to now fucking call. Wait, what is the issue here? This is random device. I'm just calling random device. Hello? Am I being retarded? What is happening? Is the light on in there? Why is the light on in there? Bro, don't get stuck. Yeah, it was on. Wait, so what the fuck is the issue here? So this is cool. What are you complaining about? Oh, seed sequences don't take regular ass numbers. What? Or they don't take sequences of regular numbers. They do? Oh, they must be the same type. So we could do thing, thing, thing. But we can't do thing, thing, thing one. No, no, no. We could do same thing. We could do static cast to the standard Mersenne twister result type. Oh god. Oh wait. Oh, it's result type. It's not a function, duh. Standard chrono or standard. Oh, I don't even have chrono here, but well, yeah, whatever. It doesn't matter. So, components we have standard seed sequence test, and we'll just initialize it with a bunch of integers. Oh, because the point is it's a seed sequence, and it takes. Well, can't I see the parameters? Yeah, it just says, oh, there's some template shit here going on. Type, which is why it can be 0, 1, 0, or oh, could it be true, false? Oh yeah, it can be a bunch of booleans. So we can do true, false. Damn. Okay, it's not saying this. This is the type, initial type, and these must all be the same type. Okay, that makes sense. And then, so what if we do auto test 1, and we initialize it to be seed sequence? Seed sequence is undefined. Hello? Oh, bro, what am I doing? Test. Cool. All right. So the point here is it is trying to make the type something else. Standard seed sequence. I don't know what that is. Constant standard seed sequence. A reference to a constant standard seed sequence. Okay, I'm not really sure. Or empty initializers will not work, or void. So none of these work. Because this returns void, this is no initializer, this is a blank initializer. So it doesn't default, it only default initializes integers. Because there's no initializer in here, it doesn't know what it is. For an int, it says, hey, you're an int, therefore your initializer is 0. But for this, it says, I don't know what you are, therefore I don't know what you're supposed to get. So it doesn't determine the type. But yeah, in some future cases where it's whatever, a seed sequence with a thing and a thing and a that, and that ends up being a type that word, yeah, okay, makes sense. Like, yeah, like if we pass the return value of different vector returning functions, and it has to be a vector that holds them all, then it makes sense that we just say auto. That way it's a vector crazy thing. Okay. Type deduction drops const from the deduced type. Oh, so if we say there's a const int a, well, it's a const qualified type. So it seems like it doesn't give a fuck about qualified types. Hey, you're a const int. Well, bro, I just see 5. What is 5? Boom. It looks at the value, not the properties of the object, I guess. In that constant, if you want to do this, it must be const. You must say const auto. Okay, yeah, makes sense. Makes sense. Yeah, because otherwise, if we had constant and then we did auto to get the value from that, we couldn't do it because it would be constant. So we would have to make something non-constant. What does that mean? Do I have to do volatile? I have no idea. Yes, we re-added it. I was trying to pop my hips by pushing my knees together. I failed. Usually happens before I go to bed. Strange type. Oh, string literals. Oh, it's a pointer to a const character. So it's not one variable that is holding a bunch of different things. It is simply a pointer to multiple characters that are read in succession. And it's const because it can't be changed. So it seems like, yeah, because it's, we know that C-style strings are created at compile time. They have static duration. They exist for the duration of the program, which means it exists and it is const. And if it exists for the duration of the program, it exists somewhere. And it seems like odds are it should probably be unchangeable if it exists. Compared to making an integer, where an integer doesn't need to be well, if it's a literal integer, then sure, it probably makes sense for it to be a pointer to a const integer too, but it's just not. You'll need to use the s or sv suffixes for the value. So we do that and say s and then sv. Oh, and we have to do yeah, I remember that. We had to do standard literals in order to actually get them. The literals. Yeah. Yeah, because we probably want to know what it is. Yo, is this something read-only that we're only seeing? Or is this something I can actually change? Well, yeah, it's just a type qualifier, I think. Oh, really? Oh, wait. Well, yeah, it's supposedly const. Okay, so if we did a const expression double, I figure it would just get double. Yeah. Yeah, it drops const. Same shit as before. So if we had auto A is a double as well, const auto would then be the const value of A. So it's a double that happens to be const. And then this is A, and it happens to be a const expression. Something, and the something is double. Yeah. Okay. Const expression is the same shit. You could have just had that before. Convenient and other benefits, really. If two or more variables are defined on sequential lines, the names will be lined up. What? Oh. Bro, chill out. It's not that insane. That's really not, that's not that crazy. 5 and 6.7. But then, really? Hmm. Bro. Avoid unintentionally uninitialized variables. Bro, why are you creating uninitialized shit unless you're talking extern for declarations? Yo? Yeah, why are you forgetting that? That's like forgetting to put your fucking shoes on in the morning when you go to work. Hello? Bro, you need to go to work for me to do anything. You need to have a value for me to be able to use you. Same shit. It's a strong analogy. Damn, playlist is done. My dead girlfriend, unlucky. Alright, go again. Third, guaranteed there are no unintended performance impacting conversions. Oh. So get string returns a view to something. And in this case, if we say get string, it returns a view to something. And it's expensive because we have to just assign this variable that. No conversion required. So not only is assigning from that expensive, but also converting. But that was the whole point of us doing string view. You're returning a view to something, or passing a view to something. So returning the value that you see, returning, hey, look there, or passing, hey, look here. That was the whole point. So I guess it's still expensive compared to what it could be. Where in here it's giving a value, but the value has to be converted to match this. Well, string view is just a pointer to a standard string, right? Which means we're returning the read-only value. Oh, so I guess maybe the value actually is explicitly different. It's not literally the value from that. It's not literally standard string here. So we have to convert it to the real standard string value. And then in this case, it says, hey, the return type for this is a string view. Therefore, this is a view of that. Oh! Okay. Alright, done for now. We'll do type deduction, benefits, and downsides. Oh, fuck. Okay. Done. I'm gonna eat, maybe even fucking sleep or something. I don't know. I'm dead tired right now. Maybe nap it up. I don't know. I hate naps though. I gotta jam it out. Oh, I'll play guitar for a second maybe. Alright. Yeah.